In this video, we will learn about the applications of principle of flotation. Now, the first application is that an iron needle sinks in the water but a ship made of iron floats. Now, we know for a fact that an iron needle or a piece of solid iron sinks in the water because the density of the iron is more than density of water. The density of iron is 7860 kg per meter cube, whereas that of water is 1000 kg per meter cube. Now, a ship is designed to have a hollow structure. As a result, a ship has much bigger volume than a solid iron block of the same mass, and its effective density is quite less than that of water. Now, when a ship enters water, it displaces a large volume of water and consequently, buoyant force, which is equal to the weight of the water displaced by the ship, is greater than the weight of the ship and load placed on it. As a result, the ship floats on water. Second is a loaded ship is more submerged in water than an unloaded ship. See, when cargo is loaded on a sailing ship, its weight increases. So as a result, the ship is submerged more in water till the weight of the water displaced by the immersed part of the ship just becomes equal to the weight of the loaded ship. Similarly, a ship will rise in water when cargo is unloaded from the sailing ship. Like this, if the weight is increased, this is the buoyant force, this is the weight. So for a loaded ship, the weight W, that is this weight, is more. So it will sink more. Okay. Or I can say it will be submerged more. Third is an unloaded ship is usually filled with ballast so as to maintain its equilibrium. So an unloaded ship floats with only a very small of it being immersed in water. So there is a risk that the ship may get blown over on one of its side due to strong winds. To avoid this possibility and to ensure equilibrium, the ship is filled with ballast in the form of sand or stone, because the density of saltish seawater is slightly more than the density of fresh water. Now, the density of saltish water is 1030 kilogram per meter cube, whereas that of fresh water is 1000 kilogram per meter cube. Therefore, when a floating ship sails from fresh water of lower density to seawater of higher density, the ship needs a lesser volume of water displaced so as to balance its weight. As a result, the ship slightly rises. And when a ship enters from seawater to fresh water, it slightly sinks more in water so as to remain floating. Fifth is a submarine may float or sink in water as per need. So, a submarine is a fish shaped, watertight, and large sized steel boat which may float on the water just like a ship or may sink inside the water at a suitable depth. For this purpose, large size ballast tanks are provided at the front and rear part of the submarine. Cylinders of compressed air are also maintained there. When a floating submarine wants to sink, the gate of the ballast tank is opened so as the water may enter and fill the ballast tank. As a result, the weight of the submarine becomes greater than the weight of the water displaced by it, and as a result, the submarine sinks. Now, when the submarine wants to rise, water from the ballast tank is forced out into the sea by allowing the compressed air to enter the tank, and then the gate of the tank is closed. Due to escape of water, the weight of submarine decreases and consequently it rises up to the surface of the water and again starts floating like a ship. So, as you can see in this particular picture, these are the compressed air cylinders. These are the ballast units or the ballast tanks, and this is the compressed air cylinders. Okay, so there are two of these at one side, and this is the propeller of the submarine. Okay, I hope this topic is clear to you. Thank you.